This question is interested in the difference between the mean and the median of a set of numbers. And if we visualize these numbers on a number line, I think it's going to be a lot easier to solve. Firstly, they're asking the mean is how much greater than the median. So you should ask yourself, would the mean be greater than the median? Why or why not? And as you look at where these numbers fall relative to each other in the number line, well, you're starting with 3 consecutive integers, essentially. Then you have, you skip one to get to n plus 4, but then we have this outlier all the way on the right at n plus 8. So that would mean that the mean is greater than the median. We know that the mean and the median would be the same number if the set were perfectly symmetrical, but it's not symmetrical. You've got that outlier on the right. That's going to drive the mean up. So yes, the mean will be greater than the median. Now looking at the answer choices, 3 of them imply that the value of n matters, right? So the first 2 answer choices imply that n is irrelevant, right? So the difference between the mean and the median would be the same regardless of where we are on the number line. But answer choices C, D, and E all imply that it matters where we are in the number line. So you have to think about that for a moment. Would the difference between the mean and the median depend on where exactly on the number line this set of numbers lives? Well, it really shouldn't matter whether the set of numbers is in the hundreds or in the thousands or in the millions. The mean and the median will just be determined by the spread of those data points, and the difference between the mean and the median shouldn't depend on where we are in the number line. So we can already pick out the right answer here. We can see the mean will be greater than the median because of that outlier on the right. And we agree that the placement on the number line doesn't matter. So the only possible answer choice here is B. Now to actually solve the question, the median of these 5 data points will be the middle data point. So that's n plus 2. And how would we go about finding the mean? There are 2 good ways to do that. So one is to just imagine that n is 0, which would mean that the data points are 0, 1, 2, 4, and 8. Find the mean of those, so 0 plus 1 plus 2 plus 4 plus 8, all divided by 5. That's 15 over 5, so 3. Now we were imagining that n is 0, so the actual mean would be n plus 3. So the median is n plus 2, the mean is n plus 3, the mean is 1 greater than the median. Another good way to find the mean of these 5 data points is to just pick, let's say, n plus 3 as the mean, just because that's somewhere kind of in the middle of the set, and then test it. So if the mean were n plus 3, we'd have a force of 1 pulling above for the n plus 4, a force of 5 pulling above for the n plus 8, and then on the lower end, we'd have a force of negative 3, right? The n is 3 below n plus 3. We've got the n plus 1, which is 2 below, and we've got the n plus 2, which is 1 below. So pulling down, we've got a 3, a 2, and a 1 for a total of 6. On the higher end, we have a 1 and a 5 pulling up, which is also 6. Oh, so those cancel out, which means we were right, n plus 3 is the mean. But I think the most GMAT appropriate way to solve this question is really to just look at the answer choices and say the placing on the number line is irrelevant, eliminate CDE, and then looking at the remaining answer choices, ask yourself, would the mean be greater than the median in this case? Well, it's not a symmetrical set, so yes, the mean will be greater, again, because of that outlier, and therefore the correct answer is B. If you found this video useful, go to quantreasoning.com for a lot more where that came from. You should also click that like button and let me know in the comments below what you'd like me to make future videos about. And of course, if you haven't yet subscribed, go ahead and do that and click that bell below so you get notified about future videos. See you next time.